Okay, this is number 7 on Are You Ready for Calculus? And we want to solve these different equations for the given or the designated variable, or the unknown. In this case, it's a, so we want to solve this for a. Again, first of all, we have a fraction, so we multiply both sides by the LCD, ABC, and that'll get rid of the fraction so we can isolate the a, wherever that may be. So if I multiply by ABC, the a's cancel, I've got BC, the b's cancel, I've got AC, the c's cancel, I've got AB. Nothing cancels here, so I've got ABC. And I'll get all my terms with an A in them on one side. So I'll subtract ABC from both sides, and I'll subtract XBC from both sides. And now we have our A terms isolated. Now I can get I've got 3 A's here, but I just want one A. I want A equals, so I just factor out the A. And then I can just divide both sides by this trinomial, and now I have my A. Now this answer is correct, but in the book they have things jiggled around a little bit, or jumbled around. So what I can do is I can multiply the top and the bottom by a negative, and that'll make this positive, and I can put the BC in front using the commutative property of multiplication. And then if I multiply this by a negative, that becomes positive, that becomes negative, and this becomes negative. There's your final answer, the way they have it for the answer sheet. Okay, let's take a look at letter B. And again, this is our expression, and we want to solve for A. I put a little mark over those just to remember. And then I have to get at this, so I'll multiply through by 2 to get rid of the parentheses. Then again, I can isolate my A term, so I can just subtract the 2BC from both sides. So B minus 2BC equals this. Then again, I'll factor out the A to isolate that, then divide by this. And this is what we have. And we do a lot of this in calculus, especially in a process we call implicit differentiation. So that's why these kind of problems help. Okay, letter C. Now this was a tricky one. And you might get a little stuck on this because if we're trying to solve for R, it's a little bit difficult to do that because, so we look here, I'll get this a little bit higher here. We've got an R squared and an R, so I've got the R terms by themselves, but if I just try to factor out an R, I'm going to have an R left in this term. So I'm going to have some problems. But if you notice this, I've got R squared and R to the first power, and it looks like I've got the makings of a nice trinomial. So if I subtracted the A from both sides and just flipped them on the other side of the equal sign, I would have 2 pi R squared plus 2 pi RH minus A. And I can notice that I have a trinomial in R. R squared, R, no R's. So if I think of this as AX squared plus BX plus C type of a trinomial, what I can do is my A would be 2 pi. My B would be 2 pi H times R. Minus A would be the C. And I can put these in the quadratic formula. And I'm going to be able to get solved for X. In this case, X is going to be R. So I just substitute that in, minus B plus or minus square root of B squared minus 4AC over 2A. I multiply this out. Negative 2 pi H plus or minus 4 pi R pi squared H squared plus 8 pi A all over 4 pi. Now, if you take, this is going to be positive if you didn't realize this is actually the formula for the area, the surface area of a cylinder or a can, if you want to think of the right circuit or cylinder as a can. 2 pi R squared, that's 2 circles. That would be the top and the bottom of the can. And this would be the lateral area of the can, circumference times height. So this is the formula for a surface area of a cylinder. And those are positive, areas positive. So this would be positive. So this whole thing would be positive. So if I subtract a positive number, that's a negative, and if I subtract this from something that's already negative, it's going to be more negative. And the stipulation is that R is going to be positive, so we don't need to worry about the minus part. Now this will be bigger than this because the square root of 4 pi squared A squared is just this. So I'd be adding that plus some more, so that would make it positive. So we can just eliminate the negative sign. That's how we get rid of that. Also, we have a perfect square factor here. 4 and 4 goes into 8 twice, so I could factor out that 4 and take the square root of 4 as 2 and bring that out in front. So this becomes simplified at this point. Now, a reason to do that is because we notice we also have a factor of 2 here, and 2 times 2 is 4, so a factor of 2 in the denominator, and I've got 2's in both terms of the numerator and in the denominator, so I can cancel those 2's out. And there's my final answer. So that worked out nicely. So I hope that makes sense. And that was a little tricky one. That might have bogged you down here a little bit. But then again, if you kind of looked at the answer, you look at the answer and say, hey, that kind of looks like the quadratic formula there, so I might have to do something like that. Okay, letter D. Here's good old letter D. And again, we want to solve this for P. So it's already pretty much set up. All I have to do is factor out the P. And I've got 1 NR, and then just divide both sides by N. 1 plus NR, and then you've got it. So that worked out nice. That was a pleasant relief after letter C. Okay. And letter E, we've got 2x minus 2yd equals y plus xd, and we want to solve for D. So I'll get the D terms on both sides. I've got D terms on both sides. I'll try to get them on one side. So I can add this 2yd to both sides. So I have xd plus 2yd, and then I'll subtract the y from both sides. And then I can factor out the D. And then again, like before, all we have to do is divide both sides by the x plus 2y, and I've isolated the D. So that's not too bad. And F, the last one. 2x over 4 pi plus 1 minus x over 2, and we want to solve for x. So again, I got a fraction, so I'll multiply both sides by 4 pi. And this leaves me with just 2x plus, and this is going to be a 2 pi factor. 2 goes into 4 pi 2 pi times. So 2 pi minus 2 pi x. And then I'll isolate my x terms. So I've got 2x minus 2 pi x, and I'll subtract the 2 pi from both sides. Then again, I'll factor out that x. And this is what we've got. And again, we do a lot of this in implicit differentiation. So this is a good technique to know. And divide both sides by the 2 minus 2 pi. Now we don't like this leading negative sign whenever we can. We've got all these 2's, so we can simplify this a bit. First of all, we can multiply the top and the bottom by a -1, so that makes this positive, positive, negative. And then again, I have 2's in all the terms of the numerator and both terms of the denominator, so I can cancel those 2's out, so I just have left pi and pi minus 1. And there's your final answer on that one. So a lot of algebra, but not too difficult. Okay, hope that helps.